Hello! So this is acid-base neutralization part 3. In part 1, we did an intro to acid-base neutralization plus examples where our ions were all either positive 1 or negative 1. So it was a 1-to-1 reaction. In part 2, we basically did an example of an acid-base neutralization where our ions were 2-to-1. So in this case, we had in our acid, so sulfuric acid, our SO4 ion had a -2 charge. So that basically caused a little bit more work. So we had to balance our equation and make sure that in our final product, we had a sufficient number of molecules so that we would have a net charge of 0. So, summary of part 2 was a more complicated question. And you've guessed it, part 3 is going to be an even more complex question. Now in part 3, what we're going to do is we're going to be looking at an example where we're going to have one of our ions is going to have a +3 charge, and one of our ions is going to have a -2 charge. And we're going to see what type of balancing we're going to have to do so we have an overall balanced chemical equation. Now, a lot of people find this a little bit tricky at first, but we're going to be doing an example. We're going to work it step by step, and hopefully this will clarify any questions that you may have. Okay, so we have our acid and our base, and as we can tell, this is our base, and what gives us our indication that that's our base is because we have our hydroxyl groups. So remember, all bases have an OH group, and we see it here, and we also see it here, and we see it here. And so if this is our base, then by default this has to be our acid. And another indication is that we know our hydrogens are pretty much by themselves. So we actually have 2 hydrogens, one here and one here. So the acid that we have in this case is sulfuric acid, and the base that we have in this case is aluminum hydroxide. So when sulfuric acid dissociates, it produces the hydrogen ions. So here we have our hydrogen ions, and it's also going to create the sulfate ion, which is right here. And in the last video, we explained why our sulfate ion has a -2 charge. I'm just going to quickly recap. Our negative and our positive charges in a molecule need to cancel each other out to give you a net charge of 0. So if we have -2 here, then we have to have +2 from somewhere else. And that somewhere else is our hydrogen ions, because we have 2 hydrogen ions that each have a +1. So +1 + 1 -2 gives us 0. So this is our acid. And now we're going to get our base. Now our base, we're going to have our aluminum ion. Now our aluminum ion, we'll notice, has a +3 charge. So where did this +3 charge come from? Well, remember, aluminum is in group 3, so that means it's going to lose 3 valence electrons. And if we remember from our math, aluminum has 13 protons because it has an atomic number of 13. So if it's losing 3 valence electrons, I'll have a total of 10 electrons. 13 minus 10, is +3. So that's where this charge comes from. Okay, and then also it will have 3 hydroxide ions. So this is our base. Okay, so I'm just going to zoom out a little bit so we can see this very well. Now, what we have is we have our acid and our base. Now, what we're going to have to do is we are going to have to match up our positive with our negative charges. So the first thing that we're going to do is we're going to match up our hydrogen ions. So let's pair those guys up. So this hydrogen ion comes here with the hydroxide ion, so it makes water. This hydrogen ion comes here with the hydroxide ion, so it makes water. And we have a hydroxide ion that is alone that needs a hydrogen. So we're probably going to have to produce another dissociated sulfuric acid to get enough hydrogens. So you know what? We're going to do that right now. Okay, so we've produced another dissociated sulfuric acid, and we're going to continue with buddying up our hydrogen ions with our hydroxide ions. So, hydrogen ion with a hydroxide ion. Oh no! Problem! We have a missing hydrogen ion and no corresponding hydroxide ion. So where are we getting the hydroxide ion? Well, from aluminum hydroxide. So what do you think we're going to have to do? We're going to have to buddy up our aluminum hydroxide and produce another molecule that has aluminum hydroxide dissociated. So we're going to do that right now. Okay, so we've produced our second aluminum hydroxide right here. That's dissociated. So now we're going to start finish continuing pairing up our hydrogen ions over here with our hydroxide ions over there. So we're going to move this, and oh no, another problem again. We have two hydroxide ions that are all alone that are missing hydrogen ions. So what are we going to do? You've guessed it, we are going to dissociate yet again another sulfuric acid into our hydrogen ions and our sulfate ions. So let's produce that. Okay, so we have this right here, and we're going to finish moving our hydrogen ions next to our hydroxide ions. So we have our hydrogen ions and our hydroxide ions all paired up. So now what we have to do is pair up our sulfate ions and our aluminum ions. Now, let's take a look. Let's move our aluminum ions over here, and let's take a look at our overall positive charges. So we have positive 3 here, positive 3 here. That leads for a total of positive 6. Okay, we're going to do the exact same thing for the sulfate ions over here. So we have -2 plus -2 plus -2, which gives us -6. Oh, wouldn't you know? We have a -6 charge here and a positive 6 charge here. And if we add those together, -6 plus 6, we get 0. And our net charge of 0 means that we have now a molecule that is balanced. So our aluminum and our sulfate are all going to come together to make aluminum sulfide. So that would look something where they're all connected to each other, which is actually really hard to see in this, but this entire molecule makes up Al2SO4 3, which is our salts. And over here, we have our water. So what we have here is our balanced chemical equation. So in our balanced chemical equation, we have 3 sulfuric acids plus 2 aluminum hydroxides give you aluminum sulfate and 6 waters. Now, there's one thing that I really want to highlight for a second. Our sulfate ion, we see right here, has a -2 charge. Our aluminum ion, as we see right here, has a +3 charge. Now, the only way that our metal and our nonmetal can come together to form a salt is if the charges are the same, because all of the electrons that our metal is giving up have to be taken by our nonmetal. So our metal has to give up the same amount of electrons that our nonmetal can handle. Now in this case, our sulfate ion, so sulfate ion right over here, can only take 2 electrons. Our aluminum ion over here can only give 3 electrons. Now we need to figure out a number that is common between 2 and 3, and that are multiples of 2 and 3. So of course we're looking for our lowest common multiple, and in this case is 6. So we need to replicate the molecule that aluminum comes in, so that we have a total of 6 electrons that aluminum can give, and we need to replicate the molecule that the sulfate ion is in, so that it can receive a total of 6 electrons. Now, how do we do that? If we're looking at the salt that's formed, Al2SO4 and we take a look at the charges, we see something quite interesting. We see that the charge of our metal becomes the subscript of our nonmetal, and vice versa, that the charge of our nonmetal becomes the subscript of our metal. And the reason why is due to our lowest common multiple. 3 times what number will give you 6? 2 times what number will give you 6? Well, if you said the answer is 3 times 2 gives you 6, and 2 times 3 gives you 6, then you would be right on both accounts. So that means if we are replicating our aluminum, if we need 2 aluminum ions, that means we need to replicate the entire molecule that aluminum hydroxide is in by 2. And if we need 3 sulfate ions, that means we need to replicate the entire molecule that our sulfate ion is in. So that's 3, which gives us our Al2SO4. And then once we figured out our aluminum and our sulfate to get our salt, well, the amount of water is equal to our lowest common multiple. So I hope that clarifies how to do a neutralization reaction when you have an imbalance of either a +3 versus a -2 charge. And this also works the same for a -3 +2 charge, which would be the same procedure. And if you have any questions, please come see me or send me an email.